My name is Phil Northcott. My background actually is silicon engineering, but after a while, after 20 years leading design teams, I realized that we had a serious crisis on our hands. And if if you look around the room and you can't tell who's the leader, it's probably going to have to be you. So I left that job at PMC Sierra and started working in sustainability because the alternative really doesn't bear thinking about. And with great good fortune, about 18 months ago, I was working with the Embodied Carbon Network and Kate Simonon in their construction task force, and the leader of that task force, Stacey Smedley at Skanska, was working on the bid for the new Microsoft project, new Microsoft campus in Redmond, and they had, and there was about a 15% weighting on sustainability in that competition, and we cooked up what if we said, let's build a new tool around embodied carbon, and Microsoft could run it as a pilot on this new campus and bring a whole bunch of people to the table because Microsoft told them to, not because they're enthusiastic, but because the buyer said that you have to do this. So we said, yeah, that sounds like a cool idea. So she pitched it, and Skanska got the job, and then all of a sudden we had to do it, which was very frightening and incredibly exciting. So we got to work. It's been about 18 months now, and the result is on buildingtransparency.org. And maybe I'll start by calling out some really remarkable groups who've decided that if governments aren't going to address this problem, that they will. I'm going to start, of course, with Microsoft and Skanska. Microsoft not only helped fund this, but has done the irreplaceable thing of bringing the business case that requires this. And now it's Microsoft and Google and Salesforce and Facebook are all behind this and doing the same thing. They're implementing it on their own buildings that they are building. Another company I want to call out very specifically is Interface. If you guys have never seen Interface talk about embodied carbon, they are a company that has religion. They are very serious. They started as a company that believed that they were in one of the dirtiest businesses in the world, and if they could clean up, so could everyone else. And it's really remarkable to see. Charles Pankow Foundation, Autodesk, Perkins and Will, the American Association Institute of Architects, a whole bunch of manufacturers have come in. Every one of these people up here has put in money. And the tool itself is free. The reason it is free is because these people pay for it. And that way nobody has to go to their boss or get an approval or anything in order to use this tool, figure out what will make sense in a procurement, because that barrier of having people have to get justification in order to use a tool like this has always been a barrier to adoption. I'm also delighted to say that we've got quite a number of very close links now with other members of the ecosystem, because we're a pretty small shop. It's myself, 6 coders, a visualization person, and an IT person. That's SeaChange Labs. But an ecosystem, a group of companies and people working together can do enormously more than any one group working alone. So one of the first things we did was to integrate with Autodesk, so you could import Revit models with Revit quantities. And I'm very pleased to say that we've just done the same with Tally. And if you know Tally, they're very good at creating bills of materials that are actually representative. So this is a really exciting thing. Another trouble we have is that there's lots of information out there in the form of environmental product declarations on what the emissions of a given material are. But they're paper. You have to go out and find 20 of them, read them, figure each one out. That is brutal to do that, okay? So we have been digitizing, and I'll show you some of the digitization stuff that we do. But also there's folks like Climate Earth and Sustainable Minds who we've partnered with who are now feeding us their environmental product declarations digitally. So when a new one is created, 24 hours later, it's in the system and comparable. Okay? So, and of course, since they're here, other than Perkinsville, I have to call out Carbon Cure, who are also sponsors of the tool. So since I'm not going to go through my first slides because you already did a very good job of them, so I'm going to skip to the second part. So this is the outfit. There's a nonprofit called buildingtransparency.org that owns the website. These and me are the directors. That's Kate Simonin, who's head of the Embodied Carbon Network. And you know, this is my team. So let's see, you guys have seen most of that, so I just skip that one. So actually, why don't I just dive right in and I'll show you what the object looks like. So when you, fundamentally what this is a procurement tool. The idea is you're building something, you want to know where you can find materials that will do the same performance job with significantly lower embodied carbon. The first thing you need is a database of materials. So we've got one, and it's strongest in concretes, where we have about 18,000 different mixes. Flooring, insulation, aggregates, steel, ceiling panels, so on. We've mostly focused on the materials that have the highest carbon intensity per unit of what they do. When you look at a building, it's the structural elements, it's the slabs, and it's certain additional things like the glazing and certain kinds of insulation because of the blowing agents that are the 90%. And my advice in looking at this is don't try to sweat the small stuff. There's too much of it. You only need to control about 7 things to make 90% of the difference. But just being straight, there's a couple of those things, wood and aluminum, where the data available is extremely thin. And this is a place where we need the community to come together and bring the industry together with to provide verified data to enable a real competition for making materials that are low carbon. And I will tell you that wood is by far the most complex. It can be absolutely amazing and it can be absolutely terrible. That depends on the details. And the details aren't simple, okay? But we have to get there because we don't have very long to solve this problem. We have maybe 12 years to get a handle on it. So we will not be able to move at the traditional speed that we did with, for example, ASHRAE. What's that?
Glacial.
That's right, but we don't have that long, or we simply won't have glaciers. I'm funnier when I'm not trying. Okay, so there are 4 main functions in this. The first is the search tool into the database. So what we've done is for every major material, we've defined a set of performance attributes that are specific to that material. So for example, it's a 28-day compressive strength, either an early or a late compressive strength, slump, and certain options, including air entrainment and CO2 curing, that you can search by. And since every type of material is different, these are custom, and we've been working with each manufacturing community to put together a set of these. We can also filter by jurisdiction. In this case, I have it set to the US. And later on, you'll see we can actually do a distance search because we have geolocated every manufacturing facility of these materials that we can find. And yes, that took a little bit of time. What you get when you do a search, and in this case you can see all I did was I searched ready mixes, jurisdiction US, valid after today, which are just the defaults. Okay, so over here we have the readout that you got. So the lowest in the entire system has 43.7 kilos of CO2e embodied per cubic meter. If you switch your preferences up here, you can switch to between US and SI units. Trying to figure it out. Yeah, it's right here. So if you pop in here, you'll see here's SI units, and I can switch to USA. Okay. And let's just pop back to ready mixes. I'm glad you like that. Yeah. Of course, this is an unreasonably large search because you can't really source concretes from the entire of North America. But if you did, you'd find there are 17,000 samples, which is a pretty nice sample size. But even if we just do something like, let's just do California or something, right? It's still fairly scary because we have a lot in California, 6,500. So what does it tell you? Okay, so the lowest was 48.4. If you go take a look at it, you'll find it's probably a backfill. That's why we have strength parameters that you can search by. 80% of the value or of the materials are at 403 or below. Okay, so if you do just a cost and performance procurement, it's probably not going to be worse than that. At least 20% of them are better than 270 kilos of CO2e per node cubic yard, right? We just switched. And what that means is if you set 270 as a performance characteristic, chances are very good that you're going to be able to get it without a significant cost adder. Does that make sense? Okay, so we call this the achievable target. Now, if you change the search parameters, somebody here want to give me a compressive strength? 3,500? 35 megapascals, okay? Oops. Okay. By the way, you'll notice that these, of course, you can see why they're 34.5. That's because they were all declared in PSI. So we have a tolerance on everything so that you don't get messed up if you're switching units. So this actually, if you take a look here, this thing says approximately equal to. This gives you a plus or minus 5%. If you wanted to be pedantic, you could switch to this, and you could actually switch it to an exact match. If you wanted, there's also, of course, less than and greater than. And just about every filter in this object has something like that. So here we got, how many of those did we get? 1,300. And you can see 306 to 429 is your range. You set 306, you're likely to get it with no cost adder. And we've actually tried this at Microsoft. They actually did this. They set a target, they got 30% reductions from the baseline, zero cost adder. Why? When you haven't been tracking something, when you haven't been optimizing it before, there's low-hanging fruit everywhere. That's where we are today. If we are successful in 5 years, it's going to be a lot harder to find 30% savings because we'll already be here, right? But right now, there is a lot of easy savings in concretes, in steels, in glazing, in carpets, in insulation. There's low-hanging fruit everywhere because we have not been tracking this, and you cannot manage what you don't measure, right? So once you've got your specs kind of a bit refined, you can hit the compare button. So here's that same search you saw just a moment ago. And then here are up to the top 7 manufacturers. And the idea with this is let's imagine that Central Concrete is your preferred supplier, right? Or better yet, let's say Cemex is your preferred supplier. You might go to them and you say, guys, we know people can get this. Can you manage it? If we set the spec of 380, can you hit it at a reasonable price? I bet you they can. They just needed somebody to ask, because this isn't rocket science, right? It means some of it's more difficult, some of it's more advanced like carbon pure, but some of it's very simple. just using enough SCMs and then using additives in order to get back some of the properties you needed. Or, if what you need is a well-controlled, nice setting time and then a nice little boost of carbon injected, foaming in little CO2 bubbles is a pretty nice technique, right? That's what these guys do. But what this does is it says, it gives you the idea of what's the art of the possible here. And when you go out, you say, I want you to generate me a mix that has these performance specs, and one of those performance specs is 380 kilos of CO2e per cubic yard or less. Bid away, right? And that's pretty much all there is to it. That's why we kind of save these images, is print it out and take it to your supplier. And you can do this for steel, you can do it for insulation, you can do it for any of the major categories. So, questions about that so far? So far, so good? Yes, sir.
Just remind me what the percentages are for the top and bottom of that.
They're 20th percentile and 80th percentile.
So that's
right?
the middle 3 quintiles?
Correct, it's the middle 3 quintiles. Okay. Right, and the assumption is that probably the stuff down here, some of it's bogus, and some of it's just inappropriate for some reason that we don't understand, right? And some of these are bogus too, right? But as long as the sample size is good, you can pretty much count on the middle being sensible. Say again?
That's a normal range, and then EC306 with water.
Yeah.
Time count.
Yeah, one. Hopefully that's true, because it's a pretty damn good sample size.
Can you then see the list of the kind of concretes or whatever that are made of that kind of?
Do you want to take a look at what they are, you mean?
Sorry?
You want to take a look at what they are?
Yeah.
Yeah, absolutely. So each one of these is an individual environmental product declaration. I'm just going to arbitrarily pick this one. Okay, so if we, so I picked it, it shows up here. This is what was declared in the EPD itself, but there's a lot of uncertainty around this. In this case, this is a fairly big one. Most likely, this one, they didn't tell us very much about their supply chain, and they didn't tell us, they may not even have told us exactly which plant it is. Okay, so one of the things you might know about measuring anything is that everything has uncertainty bounds on it, right? You guys, I'm sure this is you know this, but if you ever take a look in EPD, they never mention an uncertainty bound. The reason, as I learned when I first dug into this, is that the uncertainty bounds are very large. 20, 30, 40, 50% is not unusual. When I dug into steel with ThinkStep and got to talking to their data engineers, I asked them, why, you guys are professionals, what the heck are you doing not putting uncertainty bounds on your numbers? They said, uncertainty bound on this is 72%. We'd be thrown out of the room if we walked into a boardroom presenting that, okay? So these guys, they're not doing it because they're stupid. They're told, they're doing that because the market has a hard time absorbing uncertainty numbers. So what we're doing is we're taking the number that's brought out, we're putting the uncertainty on it, and then we take the 80th percentile, an 80% confidence line, okay? And when we do comparisons, we always do it based on, we are 80% confident that with all the uncertainty, the number's better than this. All of these stats and everything are built out of these blue numbers, okay, with the uncertainty included. Why do we do that? Well, for one thing, it's true. We really are that uncertain. But for a second thing, I want you to imagine a market. We're creating a market here for low carbon materials. And in that market, I want you to imagine that if you do nothing and you just say nothing, we're going to assume that you're as good as everybody else, that you're about average. Well, no, that's not going to work, right? Because the people who are no good simply will say nothing. The people who are good will all declare. The average will go down. Everybody, and in fact, we're not actually taking anything out of the atmosphere, right? So we do a different thing. What we do is we say, well, if you don't tell us something, if you don't disclose it, we take an adverse assumption, but not a ridiculous assumption. We call this the burden of the doubt. It's the opposite of giving someone the benefit of the doubt, okay? It's the burden of the doubt. And when we take a look at the actual, let's just pop into the actual digitized declaration itself here. Okay, what you'll see is, we don't know much about the supply chain. We don't know batch-to-batch variation. In this industry, we're looking about that much uncertainty. Okay, and this is where the guy landed. And that amount between here and here, that's the burden of the doubt. Okay, and we do it the same for everybody.
Excuse me, I have a two-part question. The first part is you went through and you used concrete as your example of Microsoft, and you commented that there in fact was no price differential. At the end of the day, the pricing came.
That's correct, yeah.
Often we'll find there will be some degree of price variance, and this is to help make market and set the benchmark or baseline perhaps in terms of procurement strategy going
That's
forward in
right.
your supply chain. That said,
We don't think zero is going to be the number long term.
right?
Yeah.
That said, if we look back in other innovative behaviors in supply chain, there will be a day when somebody maybe isn't necessarily to the same standard. They will challenge that procurement.
Yes, they will.
And so then the point about a 70-degree variance, for example, on EPDs, where do you go from a point of accountability, anticipating that the supply chain will inevitably challenge this? So I'm just wondering, as you're in your tables and you're touching on EPD, knowing that the gap is there,
Yep.
how did you address, or have you yet, in terms of auditability or accountability when one supplier reports one number versus another?
Yeah, so.
And maybe I'm jumping ahead, forgive me, but I'm just wondering if that's where you're at now to show that.
Okay, so the basic question, I'm gonna just paraphrase it back,
Please do.
is, once this gets into bids that involve serious money, the day is gonna come when someone is gonna challenge this map, guaranteed. And if we're just throwing numbers around, we gotta have something to justify it. And that's absolutely correct. So the answer is, we actually have a pretty solid system for what that has to look like, okay? And I can brief you on it. We've written up a paper on it, but it's too advanced. It's too big of a leap right now. What we're doing right now is just getting the data in place. But fundamentally, where we end up going is, ideally, where we end up is the carbon price is built into the bid and tender.
Right.
Okay, you are required to declare your carbon,
Yes.
and that gets deducted from your cost at the end. You can bid anything you want, but you're going to have to pay for what you actually do, and that is about what comes through the gate. But to get to that point, we need at the gate verification, and we need batch by batch declarations. All that needs to be automated. That's where we're going.
And I know later Morgan will facilitate, so I'd like to expand on this a bit later, right? As we move upstream from procurement into the engineering, but I'll wait for that later, if
Right.
you may, please.
But we are totally thinking that direction, only we're taking one step at a time.
Yeah, no, get it. And I'm here to want to help make the market, but I'm just anticipating the roadblocks or the inhibitors, right? But we'll come to that later.
Right?
So
And
thank
you are 100% correct, by the way. Okay, so there's a bunch more. So let's just pop in here, just to give you a flavor of some of the others, and I'm not gonna get too deep into it. If you go into wood, for example, sheets and boards, right? What you're gonna start seeing is things like stored carbon, right? So wood is unusual in that it is made up, roughly a pound of wood stores, I think, 1.2 pounds of CO2 equivalent if you oxidized it. And you're holding that. It used to be in the atmosphere, now it became a tree, now it's in your building. As long as you don't let it go, all is good. But you better track it, because that's a responsibility that you have. And there's other funny things, like for example with wood, you can't do mass, you can't even do volume unless you take into account the amount of water that's currently in the wood. So this is just to give you the idea that every one of these materials is a little bit different, and if you ignore these details, you can get very wrong answers, so just be careful, okay? We are doing our very best to code in most of these complexities so that they don't hit you unawares. But you have to. This isn't dirt simple.
Are you including average industry EPDs, or is this only product specific EPDs?
Yeah. So the question is, are we doing industry average EPDs? And my goodness, what a straight line. So the answer is yes. So we have standard EPDs. We also have industry EPDs. Industry EPDs are, since we don't know the manufacturer, we don't know the plant, we don't know the supply chain, they have quite large uncertainties on them. So for example, this is North American softwood plywood. Okay, so we give it quite a large, I think that's 42% in each direction, uncertainty. And this is more of a population than a single product, right? So, when you use that, we generally account for it at this level, not at the average level. Why? Because a decent amount of the time, that's actually going to be low for what you actually get. And I will also tell you that this estimate on uncertainty on wood is probably low, because the amount of difference you can make in terms of the soil, in terms of how much of the wood that you burn, and how much energy you expend in processing it in wood is extraordinarily large. By comparison, for example, steel, there's kind of an upper limit, on steel, because fundamentally, much of the carbon emissions from steel come from the fact you're starting with iron oxide, you bribe the oxygen with a carbon to get it to let go of the metal that we want, and the CO2 goes up, right? And then that plus energy gives you iron. Iron plus, oxygen and magic gives you steel. Cement, which is the key binder in concrete, is similar material, but or a similar process from a mathematics standpoint. It's a decomposition reaction. So you start with calcium carbonate, CaCO3. Okay, you split that into CaO and CO2. That makes CaCO3. Right, the CO2 goes up. That's about half the mass of the limestone. So 2 kilos of limestone becomes 1 kilo of CO2 and 1 kilo of calcium oxide, aka quicklime, and that is the main constituent of cement. Okay, so plus of course the energy you needed to do that, because you do that at 800 C or something like that to calcine the limestone. So almost all of the materials that you see here have a very intimate connection with CO2 that's not just energy. So people talk about operational energy. Well, operational energy and operational carbon they're not identical, but they're tied at the hip. Okay? It's not true of embodied. A lot of embodied carbon is chemistry. You have to pay attention to the chemistry. Okay? And of course, just because nothing is simple, concrete even absorbs a small amount of CO2 as it's curing. Just because nothing is simple in this world, right? Okay, so the other half of this, main half of this object is the building planner. So I'm just going to open a typical example here. Basically what we did was we started from the Skanska cost planner. We turned it into a web tool so that you don't have to have your webmaster's permission to use this, and also so that I can't camp on your network by just sending you an Excel macro that takes over your network. And we turned it into a carbon planner instead. So basically what you've got is either you can plan this either in unit format or master format, or in whatever format you like if you're willing to kind of build one yourself. And what you do, actually, I will create a new building here just to show you the process. So I'm just going to create a building project. You should give it an address, that way you can actually localize things. This is what, 611 Alexander? Oh no, forget it, I'm going with Hawaii instead. Okay, so, now we can do distance searches. So for example, I can create an element here. I'm gonna call it floor slab 1, and I'm gonna put down ready-mix concrete. Just to show you guys that I can, I'm going to do this in PSI. Oh no, actually, I'm going to be really crazy. I'm going to do KSI. Okay, so there we have 3 KSI concretes. Use this collection. Okay, so now we have, you can see exactly what it searches. Ready mixes in the US, I should have switched to Canada, but anyway. 3 KSI, valid as of today. So the quantity field is, oh, I don't know, let's put in 1,000 cubic meters times 1.03 for excess and spillage and whatever was left over in the truck in cubic meters. You could also put cubic feet, cubic yards, cubic inches, if you're so inclined. Cubits, oh, you got me, we don't have cubits. And then that rolls up to embodied carbon. In this case, 362 kilograms of CO2e, which is of course 362 tons. And then you continue as you go. And if you, for example, if you now switch to master format, oops, where did my mouse go? Where's my mouse? If you switch to master format, you can see we've already put it in 0330 because that's where it belongs. Because you tell us the material, we're not going to make you put it in master format, we already know, right? So I'm just going to switch out of this for a second and show you where you end up, which is something like this. You get a fairly full building, and oops, you know what I might do? I might just quickly switch accounts here. Typing Norman? No. Okay, so just popping into a building here. Where's our example buildings? I'll just pop open this one maybe. Okay, so what you get is a diagram like this called a Sankey diagram that gives you each. Oh, this is an old one, so it's got nasty old ones. So let me see if I can get one that's a little bit more friendly. Oops, that's a sharing settings. Sorry. There we go. That's a bit better. Okay, so here you have the different materials that went into the building. Here are the different subsections. In this case, they were just capturing the substructure here, and then the building as a whole. It gives you an idea. In this case, we've used a CLF baseline rather than conservative estimate. What's the difference between the baseline and an achievable target if you sourced all things at least the 20th percentile of best markets, best products within the things that you searched, within whatever parameters you entered for each one? Okay? And you can see kind of how it rolls up, and you can see where are there significant savings and where there are not. What you'll often find is, if you look at your carpets and your ceiling tiles and so on, there are substantial savings to be had, but they end up looking like this. The total amounts are not large. Spend your time on your structure, your enclosure, and anything that leaps out at you because you used the wrong that you included foamed insulation that uses HFCs or something as the blowing agent. You'll see things that stand out. Once you eliminate those, squish these down and you're most of the way there. And remember, all that matters is what ends up in the atmosphere, right? It's not about getting points, it's about keeping CO2 out of the atmosphere. It is. So this system is entirely focused on what's before the gate of the site, except there are just a couple of exceptions where the number that actually happens on the site is so large that we would be stupid to exclude it.
So you add it to the EPD, but you
Yes.
don't
No, it's in the EPDs. The impact of the blowing agent is in the standard insulation EPDs.
Did you include stage B and C as well?
So the answer is no, except for insulation.
Yeah, so for HSCs, you actually went the whole way, all the way to C.
We just went to the end of installation for insulation because of the blowing agents. For most of these things, those stuff in the middle, they're tiny and they just make the job more difficult. So we don't try to deal with that. We just deal with the things that you deal with in procurement, right? Not site management.
Is installation the only exception?
That is the only exception to date, is insulation. But if we find something else where it makes a 30% difference, that just happens to occur at installation, but that's the only one we've run into so far. So we have a pretty clear rule that we're A1 to A3, except when that gives the wrong answer. Yes, sir. Yes, ma'am.
You say that all of the materials would have the same scope, but some of them would include the construction impact.
Yeah, that's right. So just a very few of them where the installation impact is essentially the end of the manufacturing process. And that's true for foamed insulation, right? Or where that impact is really large, we make an exception because we're not about following a particular set of rules. We're about keeping the civilization so our kids get to keep it. So we make compromises when our, previously imagined models don't fit the laws of physics. Because the laws of physics, as you know, they don't care very much about you and me. So we better.
Is there any other situation that you have, like, that you don't, like, that you didn't find, like, an EPD with the extraction of the material and for that?
So you're asking, do we find EPDs where there's important information missing, basically? And the answer is yes. So we do one of two things when that happens. Either one, if we know what the industry average is for the missing part, we take an 80th percentile assumption of the missing part, okay? And so, for example, when somebody doesn't declare stored carbon for a given wood product, in fact, it's pretty straightforward. You look up the species, you have the dry weight of the object, you pretty much have the stored carbon. It doesn't vary all that much, right? Some other factors, you simply can't do that. And then in some cases where where there's just too little, then we exclude it altogether, right? And there are, I don't know, maybe 5 or 8% of the EPDs that we have just said, no, we cannot include this, it is just not reliable.
Okay.
Yes, sir.
Are there other bio-based insulation materials in the database beyond?
Are there bio-based?
Or are there bio-based insulation materials?
The answer is yes, of course. All of the cellulose insulations are bio-based. So yes, there's a very wide range of insulations in the system, including, the most obvious, which is cellulose.
Do you have like any innovative things like blown straw insulation and other?
We don't have
things
blown, nobody has given us an EPD for a blown straw insulation.
So basically any material that doesn't have a lobby to pay for an EPD is basically not existing in the database, is that fair to say? Or?
So the question is, does anything that doesn't have a lobby?
Yeah.
So what's going on is, so the lobbies, what they generate is industry EPDs, okay? So those are the lowest common denominator. We put up an enormous uncertainty on them. By far the focus of this is individual product EPDs. And I will tell you, just behind this thing of, do you have a lobby to pay for it? We cannot do the amount of EPD declaration that we're going to need to do in 3, 5, 8 years at the current cost of those EPDs. It has to be heavily automated. We're working really hard on that, okay? Because we cannot have EPDs at $30,000 a pop. They need to be $800 a pop. Does that make sense?
I'm interested in that, the EPD, without getting into too much detail. Tell me about the $30,000, where's the cost of doing that?
Okay, first of all, the numbers vary enormously, okay? But an example of a fairly high cost thing is that you have to send somebody on site who knows what they're talking about go through, get all of the, invoices and so on that represent the high carbon elements, get the power bills and all the rest of this, and craft a life cycle assessment. And most EPDs, in fact, also, they track about 8 things, not just carbon, right? All of those are expensive things to be doing, okay? We want to automate as much as we can and cover your ears. In some cases, I think we're going to have to step away from always doing all the measurements and just do carbon, because toxics and water use and so on, those things hurt us, right? The carbon will kill us. That's the difference, right?
Who's doing EPDs now? Each individual manufacturer is responsible for that?
No. So who does the EPDs? The answer is the EPDs are done by businesses called program operators, who are the people who stand behind the numbers. So UL Environment, SCS Global, Climate Earth, IBU, NSF, CSA. I'm running short. There's a few others in our system. Okay, but these are, and most of these players put out hundreds to thousands of EPDs, and that's what they do. They have a business that just generates EPDs.
The manufacturers pay them to do that.
And the manufacturers pay them to do it. That's correct. Yes, sir.
Is there any accounting for buildings that are designed for deconstruction?
Is there any accounting for buildings that are designed for deconstruction? The answer is no. We love that as a purpose. We're doing one thing well.
So do you mention in materials if they are recycled or recyclable? Or
Yes.
how difficult it is to recycle them?
Okay, so do we note if the materials are recycled, recyclable, or how difficult is it to recycle? The last two, recyclable and easy or difficult to recycle, we do not handle because we're focused on the procurement part of it, right? Recycled, absolutely. So if something is post-consumer, we consider its carbon expense to be amortized, fully amortized, right? If it's an offshoot of some other industry, that's not the case. It may still be primary whatever, right? Like primary steel, for example. So recycled content is probably the single biggest effect in the carbon intensity of steel, for example, right? And and aluminum is the same. It's much less true for other things, like mineral wool insulation. That's not the issue, right? So so we absolutely look at recycled content because it has a very large impact on the carbon for some materials. Okay, go for it.
Do you count for the fact that if you cut a tree,
Yes,
that means that it doesn't absorb CO2?
that's correct. It does not regrow the next day.
For the 50 years that you have to grow the same tree to do the job.
Okay, the question basically is, when you cut down a tree, you take something like at about 40 years, a tree is at its peak carbon intake rate, right? When you cut it, it's reset to 0 and then it ramps up again, okay? Whatever is below that curve is an expense, a carbon expense. Have we dealt with that properly? The answer is no. In fact, nobody has dealt with this properly. We are looking for funding and people to try to figure out how to get this right. It's not going to be easy, but it is going to be necessary, if that makes sense. We're not here to disadvantage wood. We're also not here to advantage anybody. The atmosphere is our client. And we are immensely grateful to the many donors who make that possible for us to do. But when I say us, I don't just mean me and Sea Change. I mean the whole building transparency team. Most of us, I'm privileged to actually get paid to do it, but most of us are not. The president of NKA is doing it almost half time as a volunteer, right? So it's the short answer is that's a really hard problem, and I know for certain that soil samples and satellite imagery are going to be part of the answer. Does that make sense?
Do you have an idea of how, order of magnitude impacted?
Do we know the order of magnitude, the impact of cutting a tree and letting it regrow? The answer is yes.
Do you have an idea of order of magnitude?
Yeah, we do. the typical numbers you're going to see, you know, for a wood for a cubic meter are going to be an 80 or 100 kind of a number. The variability on it is more like 200 or 300 because of factors like this. So it's basically those details are almost the entire game in wood, which is why it's such a difficult problem. But we have to get it right. Because we get it wrong, all we're going to do is enable somebody's greenwashing.
Well, basically, nothing from the forestry practice itself is included in the EPD of wood. Is that correct?
No, that's, sorry. The question was, you know, is anything in the forest practices included in the EPD? The answer is sometimes yes, sometimes no. It's all over the map. We have a philosophy for how to approach it, which is every time there's something that is not in a way that either we understand how to handle or we approve of, that we make this adverse assumption based on industry statistics. But even with that very useful crutch, this is going to be a big piece of work. Does that make sense? Yes, sir.
Sorry, so you mentioned that you've geolocated the suppliers. I don't know if that was just for concrete, but does the tool allow you to take into account transportation distances?
Okay, so what he said was we geolocated all the plants, and it's in all the materials. We've geolocated the plants where we have that information, and mostly we do. Do we take transportation into account? And the answer is, with a very few exceptions, transportation is about 3% of the total. It's not because the transportation carbon cost is low, it's because everything else's carbon cost is so extremely high. So if you ship steel from Shanghai, even though you shift it halfway around the world to get to Vancouver, it's still, you know, like 4% or something of the cost of making the steel in the first place. So the answer is yes, but we actually don't have it in here yet because we're still working on things that have 10 and 20 and 30% effects, not 5% effects. But of course, you know, with our geolocation, we're going to factor all that stuff in nicely for you. Yes, sir.
Question is that do you have an API, or in other words, do other softwares are allowed to use what you have?
Yes.
Yeah.
Okay. So this is we have an open API. This is it. This is something called a Swagger file. It's a standard way of expressing an open API. So this is currently being used by several players out there. So Tally uses it, Climate Earth uses it, and we're working with a couple others. So yeah, and of course, this is also what we use on our own webpage.
Sorry, can you repeat that? Swagger API, you said?
Swagger, yeah. The formal name is Open API.
Okay.
But the company Swagger came up with it in this format in the first place, and so they're still called Swagger files. Because I don't know. This from the industry that brought you the SCSI drive.
So Autodesk and other software platforms that designers use could be references.
Absolutely, because like we are trying to be one part of a powerful interoperating ecosystem, including with some people who consider themselves our competitors. We disagree. We think we're allies because the enemy is much bigger than any of us. But yeah, we are very open about this stuff because there will come a day when we don't have the best answer, and it's going to be time for somebody else to do something we never thought of. And you know, we want to enable that to happen because then we all win, right? So I'm going to skip over you because you've asked several questions, and I got to go for my harsh critic at the back.
I do have a question in regards to the number of EPDs.
Yes.
I remember seeing diagrams like 2 years ago that there's like 5,000 EPDs worldwide being published or so.
Okay.
And now it seems like you are in the 10,000s numbers.
20,000, yeah.
20,000 number. Is that just
Automation.
okay?
It's automation. And by the way, what you're seeing here is just the start, right? Because how many SKUs are there in the world? Ultimately, there are going to be as many EPDs as there are SKUs, right? Well, for high carbon materials anyway, right? So this is, what you're looking at is just the start, and that's why we can't do this stuff by hand. Nobody can do this in Excel, right? This has to be highly automated, and you know, we have to have a system where people can collaborate also, and if you take a look deeper into the features, you'll find that we basically built a Google Docs Lite into the whole system, complete with privacy, so that people can share data easily when they're not in the same place.
So basically the EPDs come from several sources, and
Yeah, many.
you are one of the sources now as well? Or
No, we do not
Okay.
source EPDs,
Okay.
we daylight EPDs.
Okay, okay.
But, you know, we have to put clear bounds around our role, because that's what you need to do to make a good ecosystem, right? Is to be a good player in the ecosystem.
Are most of those EPDs from Climate Earth? Is that
In terms of so the question is, are most of the EPDs from Climate Earth? The numerical bulk are Climate Earth. Those are a lot of the concrete EPDs. Why? Because what Climate Earth did was they put together an algorithm. They've got people watching their data feeds and their algorithm, but not every single output, okay? And so they're able to take a mixed design and a location, spit out an EPD, we digitize it, it's in the system, and that's how you can have an enormous sample range of real mixes. Yes, sir?
So is there a tighter integration than what you're showing here on the screen with the design tools that people use?
This is what it looks like under the hood. It doesn't look like this. I mean, when you use it, you know, when I use it, let me just pop in as, where's it? Not now. So this is, here I am Phil, okay. So, you know, if I hit import from BIM 360, all that happens is I go log in to BIM 360 with my password. We're doing something called OAuth. So we're doing what's called a three-legged authentication. In short, it's ensuring that I am what I say I am. And then what's going to happen is, you know, I'm going to grab one of these. I have to be careful not to import something that I actually have under NDA. So. Okay, but you know, if you dig into one of these, you know, you're going to see. Actually, I'm not going to go into it here, but if you dig into it, what you'll find is, you know, there's you know, your designs are in there, and when you import, you get the quantities. But of course, like everything in this world, this isn't magic. Okay, they're exactly as good as in your Revit model. How closely did you model the actual amounts? If you say that your wall is a solid rectangle made out of solid, and say that it's made of concrete, the tool will believe you. Right? So, garbage in, garbage out. Yes? Oh, she was first.
Oh, I was just wondering, because when you're designing, you have different stages of design.
Yes, absolutely.
And
Different
at the
stages of
beginning
design.
Design, maybe sometimes even before
Yep.
you have like the design. So you are talking about what materials to use and what's the best way to use them and how much. So is there any way to use this tool for just very schematic, like comparing? I just want to see if we would have wood, we would have concrete, or this and that.
Right. So what I'm going to say to you, unfortunately, is not as nice as you would like to hear. So can we use this tool to kind of sketch, okay, what if we build out of wood? What if we build a steel with a concrete shell? You know, what are these options? And unfortunately, EC3 won't help you with that. It's very good at saying between 6 brands of wood, or 12 mixes of concrete or whatever, with that match a certain spec, which one of these gives you nice reductions in CO2. But if you take a look at how the EPDs are calculated for concrete and how they're calculated from wood, they don't compare. They're not. Nobody has calibrated these in any kind of a vaguely useful way. I think, in fact, no tool can do it. But that's an I think. What I know is our tool is not reliable, and it won't be until we transform the market enough that the force of economics is getting people to challenge each other and bring these things into line with each other. Right now, there's no calibration between really broadly different materials in terms of their absolute impacts.
That is what you decide concrete to best on.
That's right. That is what this tool does really well right now. And that's just where the information level is at. It's not what we want, but it's what is.
Just,
Yeah.
sorry, 1 second. How much longer do you have in your presentation? Or are you
This is, I can go on, but this is the guts of it, right? So right now we're purely in Q&A.
Okay.
We're purely in the middle of Q&A.
So maybe another 5 or 10 minutes of Q&A.
Okay, that sounds good. Yes, sir.
You get absolute results though, in terms of kilograms of CO2 equivalents, right? So if you can set up buildings enough detail that are both credible, you could compare them.
Yes, so the notation is, I mean, we do actually give a number in, you know, our results are denominated in kilos of CO2 equivalent. So you can compare buildings, but it's just a caution. If the building, to the extent the buildings are more than just so different, the degree, you know, the uncertainty bars, you know, between them may overlap any difference, right? And that's, you just got to be careful about that. But, you know, we have pretty good, so this is tower number here, let's go tower. So one of the things that we do, well, this is maybe a very good example, but you can take two of them and you can do back to back. Now, I just picked something random, so I didn't pick a very good one. But, you know, you get two fairly similar buildings, you know, you can do the Sankey diagrams back to back. Another thing you can do that's kind of useful is you can pop into this object, for example. Oops, that's because I clicked in the wrong spot. How about I try that again, shall I? Okay, so very much like a shopping site. You know, you can, so here you can see, you know, by amount of savings. And if you prefer, you can take a look at the different materials, right? So these are four very different buildings. This is a short building, and this is a bit of a, this is a very large building, right? But you know, you can kind of see you can compare things side by side, right? This is much more useful, by the way, if you've got four versions of the same building, right? That's what it's really for.
But usually, if you have different materials, you then have to adjust the design of the building because it has, each material has different strength and different way of using it efficiently.
That is correct. So the more different the buildings are, the more you know, kind of deeper differences you have, because different things have different flexural strength, and you have to compensate for them different ways. So, but one of the advantages is you can try out two or three things, and this will, the hard work, of course, is modeling the building, but this will at least give you the idea of, with local materials, you know, that are searched, say, with 300 kilometers or within my jurisdiction, you know, what's the difference between them, and how much of a difference does procurement make versus design change, right? Because ultimately, it's only what comes through the gate that matters.
Let's just do like 3 more.
I would like to pick somebody who hasn't asked a question yet. Yes, ma'am, right at the back.
Sure. So, you know, one of the things that I think we've seen a lot is the argument behind low carbon and low cost.
Low carbon and low cost, yep.
Right. That a lot of times really making lower carbon options in design buildings is low cost. And so I'm just wondering, like, how, you know, it doesn't look like you factor cost in here, and I can see that that could be challenging in a number of ways, but how do you see maybe future iterations or, you know, ways that different data points can be incorporated to kind of make different sort of arguments still within the low carbon sort of model?
So, I mean, fundamentally, the question is, how do we factor cost into this equation? And it's a very fraught question. Just starting with, we can't be an antitrust, like antitrust constrains what we can publish about costs. Second thing is that even if we could, people are very, you know, close about that kind of things. And there's bundled prices, and it's a very complex object. So what we advocate is for the buyer to set a carbon price and to let the carbon versus cost trade-off argument happen inside the manufacturer because if you set it up right, you can actually export the carbon pricing to your supply chain. And that's a very powerful technique that's used in a number of places, not carbon. But I stole that technique from a number of places where that's how they do the trick. For example, that's typically how quality fallouts are done, right? Is that the manufacturer pays for any RMAs, right? So there's a bunch of systems like that that are fairly well proven at forcing the decision back on the guys who are actually making the day-to-day decisions that control, in this case, embodied carbon. So that is how I would do it in the end. This is a start. Did I answer your question?
Yeah, you did. I just add a bit of context, so I mean, I work for an engineering firm, and so I think the way we think about, it sounds like you're really kind of having there's a focus here on like changing the supply chain to
Yes.
how things are made. And then there's another component maybe further on down the line where we sit, which is what are the different decisions that we can make about design and materials and kind of the costs.
So let me paraphrase Don Davies, the structural engineer, back at you. What he says to me is, Phil, there's quantity control, and then there's procurement control, and they multiply together. It's quantity times the intensity of what you buy. This object right now does not help very much with quantity control. For that, we rely on mostly what's between your ears, right? I'm going to pick her because you already asked a few questions. Oh.
My hand many times.
Well, that's a good point. So ask your question. My vision's not that good apparently.
Okay,
Please.
so in one of the first slides that you showed was the bar graph, and it had kind of a comparison of many different materials that could make up a building, and so it showed like the amount of typical carbon in the volume, and so off the chart was first concrete, but the second one was flooring.
Oh, that was the number of EPDs in our system.
Oh, okay.
That was not intensity of the material.
Oh.
I do have an interesting one somewhere in the refuge of intensity of the material,
All right.
but yeah, that's not what it said.
Explains it.
Yeah,
Okay.
no, it's
Last question.
no. You got Trump. You got.
Yeah, I know you can't use that word anymore. It's
No, I know.
It's like, I was thinking about the Thornton Tomasetti study. So they had
Yes.
600 buildings, and obviously you guys are going to have in a very short time, hopefully tens of thousands of many more buildings. So being able to see patterns
Yes.
seems really powerful. How are you guys approaching not the under the hood, but just the sharing back algorithmically or whatever your summary of those patterns? Because I feel like both the patterns and also the questions that you ask, I mean, like the 7 big things take care of 90% of the whatever, like those kinds of lessons learned, I imagine will be super valuable.
Yeah, you're absolutely right, and it starts with getting decent data. So one of the things that you find right at the beginning is that people like to classify buildings into one thing. Well, if that's ever been true, it is really, really not true today. So with the help of SC 2050, I don't know if you know those folks, but SC 2050 did a bunch of input, and we have defined a set of a way of capturing uses. We're also taking a look at different wind loading and seismic effects. Because you can't compare two buildings where one has an enormous lateral load and the other one doesn't, as if they're comparable, but they're not. It's expensive to put in the lateral bracing, but I'm fairly sure I want them to do that. So we've got a bunch of the bones in place to do that. We don't have a lot of valid data in yet. That's for the community to develop in the process of following our own needs. And one of the things that we are doing to help with that is we're actually, and this is not done yet, it'll be done in about 4 months, we're putting in an anonymization system so that you put in your quantities and everything. That's all your client's proprietary data, right? or maybe your own company's proprietary data. But we've stolen an algorithm from medical privacy, from medical research systems, of randomly anonymizing things in a way that when you assemble a bunch of buildings, you get your original data back. But any one building, you can't realistically dial out the real values by looking at that one building. And like I said, we stole that almost complete from Johns Hopkins because we didn't have to come up with it. If you take a look at the stuff around personalized medicine, they use this same algorithm. So we've stolen that, and what that lets you do is it lets you, with confidence, anonymize your building, take a look at it, and if you're okay, publish it into the database, fully anonymized, so that it can actually be compared. Because ultimately, we know that we want accurate data, but we're operating in a commercially sensitive environment, and we have to be smart about that. All right, so I'm going to say my last three things back to me. First of all, about us. So we're a small, completely climate-focused cloud software team. I'm based in Coquitlam. My team is based around the world. This whole thing is a labor of love by a lot of people, and it is backed by a whole bunch of people who realize that since the people who are supposed to be solving this problem aren't solving it, that they have to act, and they're willing to. A reminder that a buyer's authority transcends borders in a way a government's does not, because that's contract law and supplier relationships, not sovereignty. And that can make a difference because ultimately this is an interconnected world, and if we are actually if we hold each other accountable, this is a war we can win. And that's it. Thank you guys very much.